My name is Colm Mulcahy. I'm a mathematician at Spelman College in Atlanta, Georgia, and today I'd like to tell you about the cylindrical surprise. So I have here in front of me three cylinders, a little one, a medium one, and a big one. And my question to you is, which of these three has the property that it's so tall that the height is about twice or more the distance around the top? So I want it to be twice as tall or more as the circumference or distance around the top. So, is the height important? Not really, because they also have width, so you have to factor that in. So you might quickly determine that this one is not going to be so tall that the height is at least twice the circumference. And then you might say, well, the one in the middle is not going to cut it either. So is it the case that this is twice as tall, it is after all quite tall, as the distance around the top, the circumference? Well, let's do a little experiment with a piece of paper. We'll discover the answer, and then we'll explain it in such a way that maybe we could have guessed the answer without doing the experiment. So I have here a piece of A4 paper, and it just so happens it has a height and a width, and the width is exactly the same as the height of the can, or the cylinder. So if I take the paper and rotate it 90 degrees, maybe it'll go around twice. Actually, it doesn't quite even go around once. So we learned something very surprising about these cylinders. The height is less than the circumference. It's kind of an illusion, and very few people would guess this in advance. Some do, but not that many. We have trouble guessing or perceiving circumference. We don't do a very good job at estimating it. But if you actually take a closer look at this cylinder, you'll see that it is in fact composed of 3 tennis balls. And that's very interesting because maybe we could have guessed what the answer was in advance. So we have 3 tennis balls here. And that means that when you put them in, the height is approximately 3 times the width. Now, what do we know about the circumference of a circle? Well, if you know a little bit of geometry, you should remember that the circumference of a circle is pi times the width of the circle. And the height of this tin or canister is 3 times the width. And you only have to ask yourself which is bigger, pi or 3. All you need to know about pi is that it's 3 point something. You don't need to know 5 decimal places. It's 3 point something, so pi is bigger than 3. The height is 3 times the width. The circumference is pi times the width. So the circumference is bigger than the height. It doesn't look like it, but the circumference is bigger than the height. Let me show you a proof with my hand, because it just so happens that my fingers can just about stretch from top to bottom of this can. That's the height. Now, if the height were really twice the circumference, which I misleadingly tried to suggest earlier, my fingers would wrap around twice, but they don't even wrap around once. One final comment. With the piece of paper here, I demonstrated that the height of the can is in fact less than the circumference. And I've already pointed out to you that the difference is really the difference between pi times the width of the can and 3 times the width of the can. So the gap is the decimal expansion of pi, the decimal part of pi after the 3. That's the 0.14159 times the width. But you can see the decimal part of pi, the part after 3, in the gap in this piece of paper. Well, I hope you enjoyed this, and again, try this out on somebody who specializes in memorizing a lot of digits of pi and see how fast they get it. Thank you.